Hey guys, so this is the video on how to complete part 3 and 4 of our introduction to thermal energy lab. So um, just to quickly review for parts 1, we wanted to investigate, okay, does heat have mass? Okay, so we should have found out that our mass didn't change, right? So that tells us even though we added heat, because heat is massless, it didn't change the mass of the object. Therefore, we can conclude that, okay, no, heat and really any form of energy doesn't have any mass. And then part 2, what we looked at is, okay, this idea of relative depth and heat transfer. Okay, so again, the key concept there is not all materials transfer or absorb energy at the same rate. Some are easier to heat up, some are harder to heat up. The example that I told the class today is, if you go and you want to boil a pot of water, okay, and you put it on the stove, within a minute or two, you can see or you can feel the metal pot is very, very hot, okay? But you could put your finger in the water and it's still cold. That's because though the metal is able to absorb that energy a lot easier, right? It's also able to transfer that energy into something else a lot easier. Whereas water, we're going to find out today, is really hard to heat up and to cool down. Okay. So the point of that was, yeah, that different materials transfer energy at different rates. Okay. So now, when we look at part 3 here, the big thing is we want to actually calculate heat now, and so we want to keep in mind that heat is a form of energy, right? That's not temperature. Okay. So we're really saying, okay, calculating energy added to something. So um, what we did is, let's go to this slide here. For this part of the lab, we had 2 different beakers. Okay. One of them we filled with 100 milliliters of water. The other one we filled with 50 milliliters of water. Okay. And we put them on the hot plate at the same time for 3 minutes. Okay. So what we wanted to look at is we wanted to figure out how much did that temperature change. And from that, we can calculate heat. Okay. So what we got for our results was this. Okay. So go ahead and pause the video, record these results into your data table, and then we're going to talk about them. Okay. Now, the mass, this is the mass of the water. That's very, very important. As you read through the lab, it's kind of like, oh, yeah, this might be the mass of the beaker. No, we want to know how much, how we want to look at the mass of the water because that's what we're going to be measuring. That's what's going to be absorbing the energy. And the cool thing is we know that if we have 50 milliliters of water, we also have a mass of 50 grams of water, okay, because there's 1 gram per milliliter when we're looking at water. So same thing here, we had 100 milliliters, that equals 100 grams of water, okay? So our T1, okay, that is our starting temperature. So the water started out at 20 degrees Celsius for both of them, okay? We put them on the hot plate. After 3 minutes, the temperature rose to 40 degrees Celsius for beaker 1 and 30 degrees Celsius for beaker 2. Now, you guys are very smart. You probably knew that was going to happen, right? The less water we have, the easier it is to heat up. And we can see that they're both on there the same amount of time. Okay, so now we're going to want to calculate delta T. So in this case, that is, remember, delta means change in, T for this is temperature. So how much did our temperature change? So that should be pretty easy. We went from 20 to 40 here, 20 to 30 here, okay? And then heat, let's just wait on heat for a second. We're going to talk about that at the end, okay? Now, for part 4, okay, part 4 was very similar, okay? So if we look down at our data table, now the only difference for part 4 is we're going to add 100 milliliters of water to both beakers, but what we're going to change this time is the first beaker we're only going to have on there for 2 minutes. The second beaker we're going to have on there for 4 minutes. Okay, so we're changing the amount of time that they're on the hot plate. Okay, and we're going to see what that does to the amount of energy that they receive. So this is what we found. So take a minute, pause the video, copy this into your data table. Okay, so now for part 4 again, we can see that we had 100 grams of water in both beakers. Our starting temperature was at 20 degrees Celsius. But after 2 minutes, okay, our temperature of beaker 1 rose by 15 degrees, right? So we went up to 35. Beaker 2 went up to 50, okay? So again, we just want you to calculate that change in temperature, Okay, now let's get on to heat. Okay, so the analysis portion. Okay, so it says calculate the amount of heat or the amount of energy added to the water in parts 3 and 4. To do this, we use this equation. Okay, so in this formula, H represents heat, okay, in calories. M is mass in grams. We're used to that. Delta T is our change in temperature. CP is the specific heat. Okay, so what we want to do now, let's add this equation. Go ahead and pause the video, add this equation into your notes. And then we'll talk about what all this means, okay? So as we look at it, like we said, okay, H is the amount of heat or thermal energy. That's going to be measured in calories. A lot of people are like, hey, calories, what? That's like food. Yeah, it is, right? So a calorie is a unit of energy or thermal energy. So when we look at, oh, our food has 200 calories, that's how much thermal energy we'll get from that food. Why do people think calories are bad? Well, because if you have too many calories, we end up storing that energy. And our favorite way to store energy as humans is in the form of fat. Um, and so that's why we get people think, oh, calories are a bad thing, but they're not actually a thing. Calorie is just a unit of heat. Okay. Mass in grams, that's pretty easy. That is going to be the mass of our water in this lab. Change in temperature, degrees Celsius, we're pretty good with that. Now, this idea of specific heat, okay? What is that? Okay, so it is, why it's called specific heat is it's specific to the material that we're looking at. Okay, so I do want you to add this definition into your notes as well. Okay, so you can pause the video and go ahead and add that in there. So specific heat is the heat or energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, so when we look at this, right, so each substance, we learned in part 2, materials or metals, even in this case, they absorb and transfer heat at different rates, right? Metals, we found out, heat up and cool down very quickly. They have a very low specific heat, okay? And it's specific to that material. That's why it's called specific heat. Water, we'll find out, water has actually a very, very high specific heat. And water specific heat is 1 calorie per gram degree Celsius. And so that's what we're going to look at in the lab. So we're going to use this, and we're going to use this equation to calculate our heat for the lab. Okay, so if we go back to, that's not what we want. If we go back to our lab here, right, we're just plugging these things into our equation. Okay, so when we go back, let's look at part 3. Our change in temperature for this one, for example, is 20 degrees Celsius. Okay, so now we want to calculate heat. So how do we do that? So let's look at our, what we know. Our mass is 50 grams. Our change in temperature is 20 degrees. Okay, and then we just found out that our specific heat of water is 1 calorie per gram degree Celsius. Okay, so all we got to do is plug that into that equation. So let's go here. That way we can, or let's do it here so we can kind of see. All right. So again, so we have our heat. We're going to plug in our numbers from the lab equals the mass of the water, which for beaker 1 and part 3 was 50 grams. Okay. We're going to multiply that by the change in temperature, which was 20 degrees. And then we're going to multiply that by the specific heat of water, right? Specific to water, which is very easy because it's 1. Okay. Now, ideally, you guys are putting units behind this because I'm not, because it's really hard to write on this. But if we do 50 times 20, should be pretty easy. That's going to be 1,000, right? Okay. And that's going to be 1,000 calories. Let's see if we can get that on there. Because we go 50 times 20 times 1 should equal 1,000. So the heat or energy that was added to our water in, this example would have been 1,000 calories. Okay, so hopefully that's helpful. Let me know if you have any questions on this. Use the data that I put on here to complete the lab. Our analysis questions then, as we go through these, this is just calculating, so filling in the data tables, make sure you have those filled in for your pictures. And then finally our synthesis question, right? So it says, look up the first law of thermodynamics and write the definition. How was this law demonstrated in this lab? Okay, so when we think about, okay, energy is not created or destroyed, it's transferred. Where did we see energy transfer, heat transfer during this lab? We saw it all over, right? In a lot of different cases, okay? Now, so it says, give a good definition of heat. What is heat? Okay, what is the unit for heat? We just learned that. Okay, and then describe what effect gaining or losing heat has on temperature, right? Because now temperature is our way of measuring it. So it should be pretty straightforward. Like I said, let me know if you guys have any questions.